Very quick bit of background. I've been working on a mobile app for about the last 18 months using JUCE. So it's my first foray into C++. Although I had experience with C and Java in the past. So yeah, it's been a very interesting and exciting journey. My main background has been in web development around the last 12 years. But I've always wanted to mix my love of music and programming, and now I'm doing it. So here I am. Great. So yeah, I'm going to be talking about some of the things I've picked up in the last few months regarding building a mobile application with JUCE. So what I'm going to be talking about specifically is mixing native APIs, basically native iOS and Android elements with your JUCE app. So the first question you might ask is why? JUCE is a cross-platform framework. In theory, we write it once, we run it anywhere. And that's what that was one of the initial attractions to JUCE. And what I found was that there were just certain things that I just couldn't get them to feel right, especially like with regards to scrolling lists and swiping navigation and all these kind of interface elements that we've all become used to on mobile devices. And I think the reason for that is that JUCE components were initially designed for desktop apps, i.e. mouse clicking, not necessarily for touchscreen devices. So there's limited support for different types of gestures, and I found it hard to get the feel right for really common user interface type of interactions. Mainly if you want to do stuff like having scrollable lists of data, and like I mentioned, swiping between pages and things like that. Yeah, the first component I had issues with was the listbox component. I found it needs a bit of adapting to respond to up and down finger gestures. And I found it really hard to get it to scroll smoothly when I had audio processing going on in the background. I realised there may be other tweaks that can be done to make it smoother, but I won't go into that now. Also with navigation, as I mentioned, swiping between pages, there's a problem in that JUCE components will grab mouse events. So if you touch a component and you've got a parent component that's trying to listen for a gesture, it's going to consume that touch and you won't get the effect that you're looking for. So after trying to make it work, I kind of backtracked and decided to try using native APIs and mixing my JUCE app with native user interface elements. So what we're going to be dealing with is on Android, as we've just seen, you've got Java code and the Android support libraries and Android APIs, and on iOS, we've got Cocoa Touch, and their language is Objective-C and now Swift as well. So what kinds of things would we use the native API for? So kinds of things would be, like I mentioned, scrollable lists, navigation, maybe user input. Another thing I found really useful is hooking up to a local database on the device. And so what things would we use JUCE for? Well, I think we know the kind of things JUCE is really good for. Audio and data processing, custom graphics and animation, and OpenGL, and also specialized GUI elements like MIDI keyboard component and anything else you can conjure up. So what are the advantages of this approach? Well, one of the really good advantages, I think, is you're presenting users with familiar user interface elements that they're used to from other apps they use on whichever platform their mobile's running. You get smooth scrolling, full gesture support, you get comprehensive toolkits that you get for free that really good, Xcode and Android Studio. There's also no need to, or little need to code in transition animations and these kinds of things that we've become used to that make the mobile experience, just a little bit more magic. These are all provided by the native APIs. Also, as I mentioned, you can use a local database like SQLite, Couchbase Mobile, Firebase. In my particular app, I've been using Couchbase Mobile, which is really good because you can sync it to a server automatically. And it means you can connect your user interface to the local database, and then on a user action, say, you can send that data to your JUCE app to pick up. So what are the disadvantages of this approach? Well, the first one that I was initially trying to avoid is rewriting my GUI 3 times. If you've got a VST as well, say. So yeah, you're having to possibly learn a new language, a new platform, writing parts of your UI separately for each platform. There's also, if you want to transfer data between the native side and your C++ side, there's different ways of bridging which can become complicated depending on how you want to do it. So how do we go about this? Well, so there's 2 sides to this. There's the user interface aspect, which is mixing your JUCE component with native UI, i.e. having kind of like a JUCE view or window within your native layout. And the other thing, like I just mentioned, is passing data between C++ and Java, or C++ and Objective-C. So a little disclaimer. I'm going to assume, for the purpose of this talk, that most of the time you only want to call C++ from your native UI code. This is all I've had to do for my app. You can do it the other way around. It's a bit more complicated. I'm going to touch on it, but not go into it. So I'm going to jump straight into Android and give you a quick run-through of how you might achieve this. So first thing is, since a couple of weeks ago, we can use Android Studio with JUCE, which is great, as you just saw if you were in the last talk. Works really well as a C++ IDE as well, because you get all the code completion. If we start a new project with Introducer, use the new Android Studio exporter, or the Android Ant exporter even, we get a generated Java activity class. This default activity is a full screen JUCE app, very much like the example you just saw in the workshop. However, if we want to include native user interface elements, we need to make our JUCE component part of a layout. And in Android, you define your layout usually in an XML file. We need to do some modifications also to our generated activity file. So the first thing is to show you a tiny little bit of code in the onCreate method in the generated activity class. So we've got basically there's a view holder, which is basically what holds your JUCE component, probably your main component. And then there's this set content view, which is a method of the activity, which just tells Android that we want the whole thing to be the JUCE component. So we can then modify this to, instead of having a full screen JUCE component, to have it as part of a layout. So here we're defining it in the same way. Here we've got our layout, which we've prepared earlier. I'm not going to show that, but there's some example code on GitHub you can have a look at. And then we're getting a reference to a part of that layout. And then, excuse me, and then we're adding our JUCE component to that part of the layout. And that's pretty much it. Also, if we want to use the recent Android support libraries, which we need, if we want a material design style, modern looking Android app, we need to change this from activity to app compat activity and do an import. And you might want to import some other libraries to help you build your Android user interface. So this is a really basic example of what the most basic app you could do doing this. So here you've got Hello World from JUCE, and on top of it you've got a material design style header and a little action button there. So moving on to, swiftly on because I'm running out of time, running on to how to how to call C++ from Java, basically. So we declare our JNI, Java Native Interface, functions in Java and implement them in C++. So here's a quick bit of code. I'm not going to linger on the code too much because I want to get into the iOS stuff. But basically, there's this very handy macro provided by JUCE and callback. Yeah, we can send strings to and from. I'm going to run through this because I want to make sure I've got time for the rest of it. You declare your method in the activity class, and then you can call it from wherever you want in your Java code. Pulling data from C++, as in calling functions in your C++ code to pull into your user interface. It's a little bit more work because you have to do a bit of jiggery pokery with, using bytes and converting them to strings and things like that. There's some code. I'm not going to go into this, but there's example code on GitHub you can have a look at. And there's an example of getting bytes and then converting them to a string that you can present in your user interface. So that's a very quick run through of how you might achieve this with Android. You can do it the other way around, and the way I've seen it done is you add methods to this JUCE Android JNI helpers header. I've not had to do this yet, but yeah, you can have a look at that if you need to do that for your app. So moving on to iOS. So your JUCE window is a UI view. UI view is kind of the basic kind of equivalent of the component class in iOS. So we can add it as a subview to any other view in an iOS app. For example, a UI view controller, which you can use to kind of swipe and kind of like stack up views and swipe back to previous views. So if we want to achieve this kind of thing, we need to modify our main window class provided by the exporter in our main.cpp file. What I've done is actually I've taken the main window class and made it a separate file, so I can include them different versions separately depending on the platform. So first I'm going to quickly run through how the first few lines might look. So here we create our UI window, which is kind of going to contain everything. We then create a UI view, which is going to contain our JUCE component. And we then add our component to the UI view as a method. I'll just show you what that method looks like in a second. And we're going to add our JUCE UI view as a subview of the UI view controller. So there you go. and that's a handy function. It's a modified bit of code given by Dave Rowland on the forum a little while ago, so thanks for that, Dave. And that's what it looks like. Really basic, hello world, and then you can swipe or hit back to go to the previous view, which might be a list of messages. Thanks. Got it, yeah. So moving on to sharing data between an iOS app and JUCE. So to achieve this, we need two layers. One that's visible to our C++ code and the other that's visible to Objective-C. So for the purpose of this talk, I'm calling them data controller for the C++ side and wrapper for the Objective-C side. The Objective-C side is actually Objective-C++, which is kind of a proprietary Apple language that mixes Objective-C and C++. So the arrows show you the imports or includes. So the data controller header is included in the wrapper implementation file. And the JUCE header, importantly, is only included in a data controller implementation, not in the header, because otherwise you're going to confuse Objective-C, because it doesn't know what to do with the JUCE header. And in the data controller header, we only expose basic C types, no C++ classes. Because the reason for that is the lowest common denominator between Objective-C and C++ is, of course, C. So here's a quick bit of code for our data controller header. You can see that I've used const char pointer instead of string to pass things around. And only in the implementation do I include JUCE, and here I can use JUCE classes. So in our Objective-C wrapper, we can take the NS string, which is the native string object in Objective-C, to send and receive data. And in the implementation, this is where it gets a bit tricky, and I got some help from this link here, which you can go and check out, which is, yeah, I'll show it again. It's a bit small there. The basic idea is, is you're basically wrapping your C++ object and kind of protecting your Objective-C code from it. And as an example, so here we're getting an NS string, and we're converting it to const char, and then we're sending it to our JUCE class. And here, the other way around, we're getting some string data, in this case some JSON data from our JUCE app, and we're then making it available to Objective-C code. So now, just by, I did call it data controller wrapper, it's now called wrapper. Got to change that. So now, just with importing our wrapper header, we can use JUCE classes in our Objective-C code. This also includes Swift, which I've really enjoyed using, actually. It's a really nice language. It's not that difficult to use Swift. Yeah, you need to create a header, like title of your JUCE app -header.h, and then you just do that import, and then that will expose the Objective-C methods to your app, so you can use them in Swift. And yeah, I'd really recommend using Swift if you can. If we want to call Objective-C from Swift, if we want to call Objective-C or Swift from C++, then one way to do that is with the pimple idiom, I'm not going to talk about that, and I haven't needed to do it, but I may do it at some point. So yeah, tying things together, the way I've achieved this in one project is, like I mentioned earlier, I've separated out the main window class from the generated main CPP, and I've called the objective C++ version that I've just run through, called it iotwindow.h and iotwindow.mm, and then in my main.cpp I just do a selective include. Yeah, and that's basically it. So yeah, thanks for listening.